we have David Litchfield, who's an independent security consultant, giving his presentation on Hackproofing Oracle eBusiness Suite. So if you would like to give a round of applause for David.
Just being here, I get a round of applause. That's great, you know. It's usually at the end of the talk. So. Okay. Sorry? Oh, thank you. Yeah, thank you. Okay, so good afternoon, everybody. We're here to talk about Oracle's eBusiness Suite and attempting to secure that. Can I get a show of hands before who actually has eBusiness Suite at work or is somewhat responsible for an eBusiness Suite install somewhere? A few people. Okay. Okay, so before we get there, who am I and why am I addressing you fine people? So I'm a security researcher. I've been in the game since about 1998. And in fact, I was a zoologist to begin with. I was studying zoology at Dundee University and I saw a film called The Net with Sandra Bullock in it. Has anybody seen the film? I thought it was a great movie. In retrospect, I understand the technical flaws in the film now. You know, they're pretty awful. But it actually inspired me to get into computers, and so here I am today, not doing zoology, but instead hacking Oracle. I've written a few books. I've written a few white papers, found a number of bugs. In fact, most of my research these days is actually focused on Oracle. Every so often I'll find a bug in other products. It's just professionally, I don't have the time to be looking at other products, so that's why most of my stuff is Oracle these days. I've written a few security tools like NGS Squirrel. Some of you may have used it. Others in the room probably have never heard of it. And I founded a few companies along the way which have all been acquired. Cerberus was acquired by AtStake, so I worked with AtStake for a wee while, and then we left to set up NGS Software. And that was acquired in 2008 by NCC Group. And I took some time off to go diving. And one of the things I like to do is dive with great white sharks. This was the other day down at the Neptune Islands in South Australia. Any divers here? I really recommend you dive with white sharks. It's an eye-opening experience. So that's enough about me. eBusiness Suite, used by a large number of organizations across the world, mostly medium to large organizations. I've never seen it in a small organization simply because of the cost. One of the customers I've worked with eBusiness Suite in the past, we were looking at installing the transparent, the TDE, transparent data encryption to encrypt data at rest. And with a 78% reduction in price, we were looking at a $2.6 million price tag with a 78% reduction in cost. So it's a very expensive product, and it's a very large product. Oh yeah, we'll be speaking about versions 12.2 and all the way back to 11.5 today. Interestingly though, on the 1st of January this year, 11.5 was desupported. So whilst we're going to talk about a lot of issues in 11.5, and we'll cover the 12.2, some of these issues are no longer going to be fixed because Oracle have, as I said, have desupported the product. A lot of customers are still on 11.5 and are looking to upgrade to the next version. So there is still relevance to looking at 11.5 too. There's all sorts of components that can be added to eBusiness Suite depending upon your tastes, but part of the problem with eBusiness Suite is it's installed with everything. It comes with a lot of stuff. It's got a huge, massive attack surface. If I look like I'm belaboring the point at the bottom, massive, ginormous, gargantuan attack surface, I don't think that's enough hyperbole. It's actually bigger than that, okay? We all know what comes with big attack surfaces as well, of course. But it is okay, according to Oracle, of the many potential SQL injections we have seen reported, we have yet to find a single confirmed example. That's in the documentation for securing Oracle's eBusiness Suite. I quickly disabused them of that idea, of course. Just, we'll skip forward ahead just to show you how many SQL injection flaws. Oh, there we go. So after a week's worth of effort looking for SQL injection flaws in the eBusiness Suite, that was a list of, these are the ones that Oracle have fixed so far. There's a bunch more. So there's a lot of SQL injection flaws in eBusiness Suite, so we'll come back. Okay. So most of you will know, no doubt, that there is a web server that feeds into a backend database server, and there's a whole bunch of architecture around that for things like concurrent processing and so on, and there's the database listeners and all that good stuff. The web server itself is going to be the primary focus of this talk because it's the easiest point of entry. One would assume that a firewall has been put in place to stop direct access to the database server itself and to the TNS listeners. However, we'll obviously find out that through exploiting some of these flaws that I've reported to Oracle, that it doesn't matter about firewalling the database because we can get access to the database server anyway and gain full control over it. There are, if you do a directory listing of the web root, there are approximately 15,000 JSPs. What we'll talk about later on is how to get rid of 99.9% of those JSPs to reduce your attack surface. Gone in release 12 is the PL SQL gateway, but it's obviously there in 11.5. There are approximately 700 accessible PL SQL packages and procedures. That again provides an attack surface. In again a recent engagement, we reduced that from 700 down to about 6. Again, a 99.99% reduction in attack surface. And the same goes for servlets as well, and so on. So I started an in-depth security review of eBusiness Suite 11.5 in November 2015. I sat down for about a week, didn't look at all the code, I just cherry-picked essentially, took some samples and found a large number of flaws. After finding 50, I decided that was enough, and I decided that in terms of attempting to secure eBusiness Suite, the approach was going to be, rather than fixing it on a bug-by-bug basis, there were just going to be far too many bugs. If we extrapolate the number of bugs I found based upon the small number of components I looked at, there was going to be a massive amount of bugs. So rather than approach it that way, I was like, well, let's just assume that all the code is buggy. What can we do to improve the state of our security such that, with a couple of sweeping strokes, we can remove 99.9% of the risk. I did the same kind of effort, a week's work on 12.2, and again, there were a whole bunch of security issues reported to Oracle. Most of those have still not been fixed at this state. So this is the unfortunate thing. I was hoping by this time, the presentation came around, that I would be able to present all my findings, and unfortunately that is not the case. So there's not massively truncated, but there's going to be a portion of this talk missing. So suffice it to say that the principles remain the same. There are bugs, we can get rid of them. Okay, the actual bugs aren't too important, I guess, given that there are so many of them. So we'll look at some of the issues that are of interest in 11.5. We'll start with some really simple ones. So all the JSP files are stored in a directory off the web root called /OA_HTML. There are other subdirectories within there, one of those being bin, which is really interesting because inside bin there's a file called appswebs.cfg, which contains things like usernames and passwords and configuration information, and also some of the applications used to connect to the database, like binary applications to connect to the database server. And if those error, they'll create an SQL net.log file which we can gain access to simply by using some of these other directories, /HTML, /JInitiator, which point to the same physical location on the file system. So that's just one of the gotchas to be wary of when you're locking down eBusiness Suite 11.5. Remove HTML, remove /JInitiator. Trusted.conf cannot be trusted. That's really ironic. So if we look at inside the trusted.conf file, there's a whole bunch of location directives, Apache location directives, and they've not really been thought out well. So for example, we're not allowed to get access to the DMS0 thing, which gives us information about memory usage and configuration information and so on. But by appending so the default is deny from all, essentially, so no one should be able to access that. But of course, by simply adding another /, we suddenly get access to DM0. And there are a whole bunch of things that are protected with a location directive that we can simply bypass, essentially. So if you see all the double slashes there. So even if someone has protected the SQL.log file with a location directive in 08 HTML, which one would prefer to do, then it can be typically bypassed again with the double slashes. So there's a whole bunch of issues with trusted.conf. But these are just boring standard Apache failures that it's not Apache's fault, it's Oracle's problem. So we'll look at the PL SQL gateway, which is a much more interesting proposition. So as I said earlier, there's about 700 PL SQL packages and procedures. The PL SQL gateway is a really interesting thing. Essentially what it does, it takes a request from the web client and passes it directly to the database server for execution. So essentially the web client says get www/pls/foo/xyz.pqr. Now what the web server does, it takes xyz.pqr, sends it to the database server and says, please execute xyz.pqr for me. Even if it doesn't exist, it executes in a typical PL SQL gateway situation. So to prevent abuse like that, Oracle introduced this FND-enabled PL/SQL, and essentially it's a list, it's a table that contains a list of executable PL SQL packages and procedures that one can access via the PL SQL gateway. So rather than looking at all 700 of them, I took a sample of 40. 12 of those had SQL injection issues. 15 had XSS and 2 had a denial of service issue. The simple denial of service issues where they take user input and pass that to a loop counter, and we specify a really big number like 4 billion, and it causes the database to spin at 100% and so on whilst it's doing that processing. Most of the SQL injection flaws were your standard run-of-the-mill, inject your SQL here, gain full control of the backend database server. Really boring, everyone knows about the kind of stuff, but there's some much more interesting, slightly harder to exploit issues, which we'll talk about here, because that's what we do, it's fun. So there's a package called hr_util_disp_web. This has been patched, by the way. It has a procedure of it called Dexel, DXL, I don't know how you pronounce it, I'll just go with Dexel. And it takes a single parameter, a p_URL. Now what it does, that p_URL is passed to the icxcore.decrypt2 function. Once it's been decrypted, it's then embedded within a begin and an end block, an anonymous PL SQL block, and then it's executed via HR general utilities execute dynamic SQL. So the question is, what does icx_core.decrypt2 do? Well, it takes a number. That's all it is. It's not actually encrypted. It's just a number. And what the decrypt2 function does is takes that number and looks up the text column in the icx_text table. Whatever that text is, it embeds within the SQL statement and executes it. Now, because that table is in the database server, we have no direct control over that. If we could insert into that table somehow a record, like Pragma autonomous transaction, execute this, go and create a user account for me, that would execute. And it would execute with the privileges of the apps user, which basically is one small step away from having sysdba privileges. And we'll talk about that later on. In fact, it's trivial to get sysdba privileges from apps. But essentially, we as an outside attacker, without a username and password, don't necessarily have direct access to the database server at this stage of the game. So the question is, how do we get stuff in that table that allows us to execute arbitrary SQL? Well, fortunately, Oracle again comes to the rescue for us. If we can encrypt stuff, if we can find somewhere in the web application that calls icx_core.encrypt2, that will take our clear text and put it into that table for us. Now, in the same package, there is a display fatal errors procedure. And as you can see here, it takes whatever the p-message parameter is, and then essentially encrypts it for us, and redirects us and gives us a number. So under the covers, that encrypt2 inserts into the ICX text table whatever we send it and gives us a number back. So the attack sequence goes like this. First off, the arbitrary SQL we want to execute is http.p dbms aw interp sleep for 10 seconds. Now this dbms aw.interp is a nice little function we can use to test whether an application is vulnerable to SQL injection or not. If it sleeps for 10 seconds, we inject it. If the application sleeps for 10 seconds, then we know it's vulnerable to SQL injection. Our SQL is executing. And we embed it within an http.p just for to pass through without any problems. So we execute that with the display fatal errors, and that redirects us to the same page, but now with a number. That number we then take and request with the DEXL procedure. And what happens is the database server looks in the ICX_text table for that number, takes out the text, embeds it within the anonymous PL SQL blocks, and executes it for us. And the application hangs for 10 seconds. And that executes as the apt user. So it's not a trivial SQL injection flaw. It's slightly harder to exploit, but much more interesting. When you keep on finding SQL injection flaws and it gets really boring, when you find something a bit more harder to exploit, it's a lot more fun because it's like, well, actually now it piques my interest. Yeah, what was ironic was the whole statement in the beginning about of all the SQL injection flaws we've had reported to us, none of them have been confirmed examples. In the time it took me to type that, I found, in the equivalent time, I found a SQL injection flaw, which was the ironic thing. They're that easy to find in eBusiness Suite, unfortunately. Another quite cool example is the execute procedure on the Oracle SSWA package. So what happens here is we've got slightly different decrypt function. This one is actually, I'll use it loosely, encrypted. Now, the E parameter basically is passed to the decrypt function, and that block there, the !38fc0, decrypts to this sequence of numbers at the bottom. Now, that 2633 basically is passed to, internally, the run function. Now, what that does is basically looks up a web HTML column in the F&D form functions table that equates to that given function ID. So in this case, 2633 translates to ICX_change_language.showLanguages. Now, in the code, if there is a parameter called p and it's non-null, it too is decrypted and then concatenated to the arbitrary block of SQL that's going to be executed. So in our case, if we, using the encrypt function, if we need basically our own version, our own copy of eBusiness Suite, essentially we encrypt our arbitrary SQL. In this case, it's bracket semicolon http.p user semicolon end semicolon minus minus equals A. The reason for this will become clear shortly. What is concatenated, or what is eventually executed, is this. So remember, we've passed it the encrypted text that decrypts to 2633. That takes from the table ICX_change_language.showLanguages, and then the P parameter is concatenated to the end. Now, by appending the minus minus at the end, we essentially cut off the rest of the SQL that is supplied by the application. So essentially, we're embedding our own arbitrary SQL to execute, in this case, http.p user. So we go ahead and execute that. The E parameter, as I said, is the encrypted text for the 2633. And the P parameter is our modified http.p SQL. And if we look in the source, we can see http.p user executes, and we can see we're executing as the apt user there. Now, where are we? There's a whole bunch of issues like this in 11.5 and 12.2 and earlier. These are the ones that were fixed. These were fixed in January. except the bottom three on the right-hand side, those CVE IDs were given to me by MITRE because Oracle have said they're not going to fix those issues because the product is now de-supported. So there's a whole bunch of issues that have not been fixed yet in the 11.5 that Oracle have said that they're not going to fix. So I've gone to, well, one of the talks earlier, actually, Darren would know about this more. There's been problems with MITRE not being able to churn out CVE IDs quick enough. I'm one of the few people who've had good experiences with MITRE. I've managed to, I've sent them a request for a bunch of CVE IDs for some issues I've found, and they've responded within a day and issued me with a bunch of CVE IDs. So that goes counter to what some other security researchers are unfortunately experiencing right now. But that was a wee aside. Okay, moving on to eBusiness Suite 12.2 and earlier. Again, I spent roughly about 80 hours doing a security assessment on it. So in certain respects, there is a larger attack surface in 12.2, but some of the key components have been stripped out. So for example, the PL SQL gateway is no longer in eBusiness Suite 12, which is great because that removes a whole bunch of attack surface. But if we look at the number of servlets, there's about 80 servlets installed by default, whereas there's about 16 in 11.5. So we've sort of shifted the focus of the attack surface. There are at least 2 that I know of Java deserialization issues. Basically, they take an input stream and then do a read object on it, which allows us basically using some Java gadgets to execute OS commands. Those are in the process of being fixed. There were 8 SQL injection issues, some in servlets, some in JSP files. I lost count of the cross-site scripting flaws. And there's a whole bunch of not minor issues, one-offs here and there, like cookie exposure. We can force the web server to make arbitrary GET requests to other web servers, and in doing so, leak other information. There's directory traversal, XML external entities, denial of service, and so on. Most of the issues for eBusiness Suite 12.2 we're waiting for patches on still, unfortunately. So I don't want to go into the specifics of what these issues are. So here's another problem, and this will come up again when we come to looking at securing eBusiness Suite. I spent a wee while today looking for many ways to skin a cat, a synonym, and there's nothing suitable, which is really ironic, Essentially, let's look at a specific SQL injection flaw. In the BIS AKRGN.JSP JSP file, there is a simple SQL injection flaw. Essentially, it takes some user input and embeds it in a dynamic SQL statement and executes it. You can see that %27 there is a single quote, and we pipe a character, the letter A, and enclose with the double pipe and the single quote. Simple SQL injection. Rather than put tr, we can put a different function in there and have it execute for us. We'll talk about batching, how it's not batching, but Oracle doesn't batch SQL statements, but there's a neat trick to get around that so you can execute any SQL you want to. We'll come back to that in a minute. But the point is, this JSP file is vulnerable to SQL injection. So we might look at that and say, well, we could use a mod rewrite or a location or a mod security directive to block access to that file if for whatever reason we can't delete it. The problem is, there are multiple ways to access that file. So one of them is through using the rf.jsp, the run function JSP file, basically. Because the BIS, I'll just call it the BIS JSP file, that has an entry in the F&D form functions table for the corresponding function ID of 11091. So we don't access the JSP page directly. We can indirectly access it through rf.jsp. So even if we block direct access using, as I said, a location or a mod rewrite directive, we can still access that SQL injection floor by going through rf.jsp. So we have to be wary of that. Another one, oh, and again, if you want to block it via rf.jsp and you look for the function ID of 11091, then be careful of things like leading zeros and so on, that kind of trick to bypass the prevention mechanism you use. Another way of gaining access to this BIS JSP file is through JSP forwards. There's a whole bunch of JSPs that take arbitrary user input and use that as part of a JSP forward. So in this case, we've got one called QOT scop add service.jsp, and it takes a parameter QOT form main file, which is the name of our JSP page, and once that's included, once that's been forwarded, we can then just pass it the psearch by parameter, and again, that executes. So we don't necessarily directly access the JSP page again. We can indirectly access it through another JSP. And there's lots of them. So we have to be really wary of this. Using things like a location directive to directly block access is not sufficient. We have to be really careful on the way we approach these things. So if you look at all these files, these are examples where they take a user input and use it as JSP forward internally. What's an interesting thing about this as well, in 11.5 you can only include, you could only forward to other JSP pages or HTML pages, whereas in 12.2 and earlier, you can request any kind of content. So for example, an XML file or a log file or whatever it happens to be. So again, we can bypass things like location directives and mod rewrites to gain access to files we shouldn't have access to. So anything in grepping all the JSPs for things like get parameter that's being passed to a forward page will find you these kind of attacks. Some database issues, right. There's a lot, okay? So I don't want to go through them all now because how we're doing for time? 10 minutes, okay. We'll talk about some really quick ones, okay. So the apps user basically does, he's got so many privileges in the database server, but Oracle goes one step further and gives apps the execute privilege on the dbms_sys_SQL package that essentially allows you to specify a username, a user ID to the pass as user function that basically says if we pass 0, we can execute code as sys. That's why I said earlier, apps is one step away from sysdba because we just essentially use the dbms_sys_SQL package to execute code as the sys user from apps. The reason apps has this privilege is for one reason and one reason alone, because at some point in the code, there is something that executes alter user, arbitrary user with such and such a password. So it strikes me as being rather silly that we don't give the apps user the alter user privilege directly, but rather give it access to dbms_sys_SQL that allows them to execute any SQL rather than restrict it to the auto user. So that was reported to Oracle, and I'm not sure if they've actually fixed. No, they have fixed that in April. They fixed that in April, so apps no longer should be able to execute dbms_sys_SQL. In certain versions of eBusiness Suite 12.x, public has been given the index privilege on this sys.dual table. Now, what that means is anyone that can create a function can create a function-based index on sys.dual and execute code as the sys user. Again, that's a really worrying situation to have. Again, that's all been fixed now. There's a whole bunch of issues where things like some VPDs, virtual private databases, the function that's used to specify the execution context has global variables in use that we can essentially set as a user and have that SQL execute via the global variable anytime we call something in the virtual private database, essentially. There are, I spoke earlier about the index privilege. It's a generic issue with Oracle whereby if you have the index privilege on another user's table, you can execute code as that user by creating a function-based index. And when someone queries that, the function-based index executes the function, and that function executes as the owner of the table. There are 26,000 instances of the app's user having index privilege on another user's table. 26,000 instances of that particular vulnerability. So does anybody get the reference to the margins too narrow? Fermat's last theorem? I didn't even get a snicker. Okay, so we're running out of time, so we're going to really shoot forward with this. Okay, you can literally make a 99.99% reduction in attack surface for eBusiness Suite. It's the greatest thing since sliced bread. If you want to sell this to management, and you can show them this, the improvements you'll make as far as security is concerned, it's an easy win, essentially. So if we look at the JSPs and say, we've got 15,000 JSPs, let's remove them all except those which we need in our day-to-day business operations. First off, we look at the access logs. What JSPs are we actually using on a day-to-day basis? Go back as far as you possibly can, of course. Speak to the business apps people as well, the biz apps people, because they'll know what components they're actually required to use for their day-to-day business activities. But it's not enough just to look at the access logs because, of course, as we mentioned earlier, access to a lot of these things can be done through rf.jsp. So we need a list of JSPs that we request via rf.jsp and add those to the whitelist too. And then, of course, there's a whole bunch of, if we need to give access to foo.jsp, we need to review the source code for foo.jsp to ensure that it's not including or forwarding to another JSP underneath the covers, and then do that recursively, of course. In a recent engagement, we went from 15,000 JSPs to just under 200, which is actually better than 9.99% reduction. It's 9.99999 and so on. The servlets, again, went from a list of 80 servlets down to 2, which is 97% reduction. Specific to, sorry, I'm just rapidly firing through this. The slides will be online later on if you want to browse them at your leisure. Securing the 11.5 is pretty much the same as 12.2, except we have to worry about the PL/SQL gateway. Again, you can do the same kind of exercise, look at what's in your access logs, what's being requested, and disable everything else, basically. There's a column in FND enabled, PLSQL enabled. It's either Y or N, essentially. If it's N, the attacker should not be able to get access to it. And again, we went down from 700 to 6. So again, realizing a 99.99% reduction in attack surface. So the idea basically is, and this is doable, I've done it, you strip everything down and review what's left. Use mod rewrite and mod security to protect everything else. Don't use location directives because Apache are deprecating them. And one of the real benefits, one of the real improvements you can make to this is rather than just leaving people in the dark, if something does go wrong, if you strip all this stuff out and one of the BizApps guys does actually require access to a specific page, leave a 404 explaining what the situation is, go to, file a support request to have the file re-enabled, and so on. So we've got about 2 minutes for questions, if there are any.
We don't have any questions. I did have one myself.
Sure.
And that is kind of, what's your take if you are going to compare the whole Oracle to Microsoft SQL Server to MySQL? What is US going to say? Use one yourself. What is your, in a sentence,
SQL Server rocks. Microsoft SQL Server rocks, yeah. If you look at the number of flaws that have been found in SQL Server, I want to go back actually to SQL Server 2000. Who remembers Slammer here? So Slammer was based upon some of the code that I presented in July 2002 at the Black Hat security briefings in Las Vegas. And it was a real problem. Obviously, took down certain parts of the internet and so on. But the point is, that and a few other issues. Myself, Cesar Serrado, Chris Anley, and a few other people were really bashing at SQL Server at the time, looking for flaws essentially. And within the space of a few months, we'd reported 26 to Microsoft, and Microsoft were getting those fixed. But after Slammer, those kind of episodes, Microsoft was in the process of developing SQL Server 2005. And they basically took everybody off SQL Server 2005 development, went back to SQL Server 2000 code, and did a massive security review and fixed all the code up. Then they went back to SQL Server 2005 and did the same exercise. In the years between 2005 and now, I think there have been 8 security flaws that would be classed as high risk to critical in SQL Server 2005. For that many years, 11 years, that's an outstanding record. And Microsoft SQL Server is the poster child, essentially, for Microsoft's security development lifecycle, SDL. Okay, maybe their browser stuff's not so great, but if you look at their server stuff, they've done a really great job. Oracle, on the other hand, are fixing every 3 months critical flaws in the database server still. There was a period where, it looked like they were tailing off, but the numbers have actually started going back up again. So in answer to the question, which database server do I think is best, it's my personal opinion that Microsoft SQL Server is the strongest as far as security is concerned, but not necessarily features. And let's face it, at the end of the day, the business is what's the important, is the most important thing. And if they've got the features, yeah.
And so MySQL,
well, the last time I looked at MySQL, I found a format string bug and a buffer overflow within about 2 lines of code. But that was a long time ago, 2004. And I thought, no, I don't want to touch that because I had other projects on. There's been so many issues in the past with MySQL, things like you set a flag and only 1 byte of the password is checked, during authentication, just things like that. It's probably a lot better these days, but I've not had an opportunity to do a proper code review since then. There was a question here.
Yeah, I guess we saw some press recently about SAP competing products in the similar space, and the clear thing that I guess most of us have seen, they never get patched. The CFO's area is highly resistant to upgrading stuff. And so I'm not trying to make a statement.
Yep.
Clearly, stuff might have been released in April that doesn't get patched. 2 questions is, what's your experience in how long people get around to patching the eBusiness suite? And secondly, you're going to have a look at SAP.
I'm not going to look at SAP simply because I've got enough. I've got two young children, and they take up all my spare time right now. I used to be where I used to be in my spare time. I used to hack, and have fun with this stuff. But now my kids, have changed all of that. In terms of the patching question, it's not uncommon to see people who are 6 months behind on patches. They want to wait for, they have a twice yearly patch cycle, and they'll install a patch from, I'm not going to mention any names, but they might install, say, for example, the October 2015 patch today. So they're behind, but they want to give the landscape a chance to settle down and see if there's anything wrong with the patch, because if they install the April patch now, there might be a reissue of the patch and all that work is gone to naught. So typically what I see in the industry is people using older patches because they're more stable. I don't see very many people not patching their stuff though these days. And if they're not and they, getting, my strongest recommendation I can make is patch your stuff. And if someone like the CFO is pushing against that, then, see, in Australia it's slightly different because you don't have SOX compliance. In America, a lot of the SOX stuff is stored in a database server, in eBusiness suite stuff, and they have to certify their financial record and say no one's tampered with this stuff. But if I can drive a bus through and tamper with those records without anyone knowing, then it's really difficult when it comes to SOX compliance. But because that's not necessarily, there's no driver in Australia to patch because there's not necessarily the compliance aspect. But certainly there is in America. Sorry, that was a long rambling answer to your question, but I hope I covered it.
And the last part of the answer was really, I see it very differently here, so thanks for that perspective.
Yep, no worries.
Okay, anyone else?
Sure. Hey, how are you doing?
Just interested in your thoughts on cyber insurance. So I think that is a relatively new player in the game. And if you're now a big business using Suite A versus Suite B versus Suite C, I can see that in the span of about 10 years or so, this is not going to happen quickly, but your insurance premiums may start to vary. Do you have any thoughts on that?
I do not, is the simple answer. I know it's I've got a few friends like, Mudge, who's looking at this whole, cyber insurance and underwriting labs and stuff, but I've got no experience with it, so I don't want to waste your time with a crackpot answer.
And on that note, we'll finish up. Thank you very much. If everyone could give David a round of applause.
Thank you.
Thanks, guys, and we'll break for lunch. Don't forget to leave feedback, and we'll have the speed debate after lunch.